Assalamualaikum and hi everyone. Let's continue our lesson in lecture 204, topic 7, normal distribution. Learning outcomes for 7.2 normal distribution are to standardize the normal random variable and to determine probability by using the standard normal distribution table. Let's recall back. To standardize a normal random variable x to a standard normal random variable z, the following formula is used. Z is equals to x minus mean over standard deviation.
Okay, let's continue. To standardize a normal random variable x to a standard normal random variable z, the following formula is used. Z is equals to x minus mean divided by standard deviation, where this is the symbol of mean and standard deviation. Okay, so usually in normal distribution, we will get x distribute normal distribution with mean and variance. Okay, so we need to change to the standard normal random variable z, where 0 is a mean and variance is 1. Because of this is only the mean and variance that we can read from the table, from the statistical book. Okay, so for this example, first example, given x is a normal distribution with mean 100 and variance 16. Okay, so now find Px greater than 104. Okay, so first, the things that we need to do is we standardize from x, we change to z by using the formula. So this is the capital letter, z in capital letter. Okay, 104 minus with mean, so 100. Okay, divide by standard deviation. So because of the variance here is 16, so we need to taking square root of 16 to get the standard deviation. And then we need to simplify this value. So 104 minus 100 divided by 16 will be equal to 1. Okay, so from the table, if we look at the normal distribution table, so we will get the value of Pz greater than 1 equals to 0.1587. Okay, so because of z equals to 1, when we do in the bell shape, so 1 is around here. So the area that equivalent to the probability is here, which is 0.1587. Okay, so next, for example 1b, so Px less than and equals to 92. So first thing that we need to do is we need to standardize by taking 92 minus with the mean 100 divided by 16. Okay, and then you will get Pz less than and equals to negative 2. Okay, now if we look at the bell shape, because we need to know where is the area if we take in z less than negative 2. So let's say negative 2 is here because of 0 is in the middle. And here this side is positive z. So here is negative z. So we got negative 2 and then z less than, which is this area here. So now we need to find z less than equals to negative 2. But we cannot read z negative number from the table. So we need to change or reflect to the positive side. So we change into z equals to 2. And this area is equals to this area, which is the greater than 2. So this area is equivalent to z greater than equals to 2. So now we can read from the table. So we will get 0.0228. Okay, now let's do example 1c. So we have x less than Px less than 115. So first thing is we need to standardize. So by taking 115 minus with 100 divided by standard deviation, which is 16. So when we calculate, we will get PZ less than 3.75. Okay, now if we look at the bell shape, because of all the normal distribution, the probability is equivalent to the area under this bell shape. So that's why we need to do this bell shape. So 3.75 is positive number, which is around here. Okay, and then this area z less than 3.75 is here. So means that this area is greater than 0.5 because of half of the bell shape. When we shaded the area, half of this bell shape were given 0.5. So this area is greater than 0.5, but we cannot find it in the table because of the z is less than. So means that we need to find the area by taking 1, which is the area of all the under this bell shape, 1 minus with the area that greater than 3.75. Okay, now we can read the value if we taking z greater than 3.75. So from the table, we will find that this will be equal to 0.00009. Okay, now we take 1 minus with 0.00009 equals to 0.99991. Okay, so this is the answer. Okay, and then 1D. So Px greater than 87. So first we need to standardize by taking 87 minus with 100 divided by 16. Okay, then we calculate this. So we will get z greater than negative 3.25. Okay, now if we look at the bell shape, so the negative number z negative 3.25 and the area is greater than, so means that it's here. So this area is greater than 0.5, but we just can get this area by reflected to the positive side and taking at the z 3.25. So this area, the shaded area, is equivalent to this area, but we cannot find this area directly from the table because of z cannot read from the less than side. So we can just read the z greater than. So we take 1 minus with pz greater than 3.25. Okay, now when we read from the table, so we get 0.00058. So the answer is 0.99942. Okay, now let's try this example. Okay, given x with a normal distribution where mean equals to 60 and variance equals to 4 squared. So means that your standard deviation here is equals to 4 because of the given questions here give in this form. So 4 squared. So means that your standard deviation equals to 4. So if we get the questions like this, where we need to find the value of k instead of finding the probability, but the probability is given here. So the things that we need to do first is you just standardize, where we need to we need to take k minus with mean is 60, okay, divide by standard deviation 4 will be equals to 0.1. Okay, so this is special case because when you look at the probability where it has only 1 or 2 decimal places, so we need to look at the table 4 from the normal distribution table. So Pz greater than k minus 60 over 4 equals to 0.1. So we need to estimate where is the k minus 60 over 4 lying at. Okay, so because of this is z greater than means that the area is at your right hand side, and then the probability is 0.1, so means that k minus 60 over 4 is around here, and the area is 0.1, means that it's on your right hand side. Okay, now if we look at in the table, the value of z that give you probability 0.1 is 1.2816. Okay, so means that this is equivalent, this is equal, so we can take k minus 60 over 4 equals to 1.2816. So k equals to 65.1264. So this is the answer.
For B, we want to find probability of x greater than k is equals to 0.7. Okay, now let's use the bell-shaped curve. But first we have to standardize. Okay, we use the formula, so z will be greater than k minus 60 over 4 is equals to 0.7. Okay, now we want to use the bell-shaped curve. 0.7 is more than half, so we can say that the value of k minus 60 over 4, okay, at this place. Okay, this is the area that we will get 0.7. Okay, now because our value is on the left side, okay, from 0, we have to minus with this area. So what is the value for that area? We can use 1 minus p, z is less equals to k minus 60 over 4 is equals to 0.7. Therefore, our probability now will be equals to 0.3. Okay, this part is 0.3. Now we want to refer to table 4. Okay, let's find the value of 0.3. So for probability 0.3, the z-score is 0.5244. From the table, pz is less than 0.5244. Don't forget to put negative value, okay, because k minus 60 over 4 is on the left side. Then we can compare the value of k minus 60 over 4 is equals to negative 0.5244. Therefore, our k is equals to 57.9024. For C, we want to find the probability when x less than k equals to 0.2. First, we standardize, so z less than k minus 60 over 4 is equals to 0.2. Now we want to shade the area in the bell curve. This is the area. Okay, for z less than k minus 60 over 4. Okay, 0.2. Okay, now we can refer to table 4. For table 4, at 0.2, the z-score is 0.8416. we can write PZ less than 0.8416. We write negative, okay, in front of the value because K minus 60 over 4 is on the left side. Therefore, K minus 60 over 4 is equals to negative 0.8416. Then we will get K equals to 56.6336.
Okay, now we do number 2D. So Px less than K equals to 0.8. So first we need to standardize Z less than K minus 60 over 4 equals to 0.8. Okay, now we need to estimate in the bell shape. Where is the value of K minus 60 over 4? Where when we shade the area that less than that number, it will give you 0.8. So means that K minus 60 over 4 is around here, because of when we shade this area, it's equals to 0.8. So now we cannot read the Z that less than, so we just can read the Z that greater than. So the area that greater than this number will give you 0.2. So we can just directly write like this. So Z greater than this number, K minus 60 over 4, will be equals to 0.2. So from the table 4, so we find that PZ greater than 0.8416 will give you 0.2. So this is equivalent to the K minus 60 over 4 will be equals to 0.8416. So K equals to 63.3664.
Another example, X has normal distribution with mean 40 and variance is sigma squared, and Px greater than 50 equal to 0.1190. Find the value of sigma. So we draw Px greater than 50 equal to 0.1190. Mean is 40 and we draw line 50, and the area Px greater than 50 is 0.1190, and we change to Pz greater than 50 minus 40 over standard deviation equal to 0.1190. Okay, we look at the condition. Okay, we have symbol greater than and the area is 0.1190. So both conditions are suitable for us to see the answer from the table. Okay, from table we look at 0.1190 and we look at the first column, we get 1.1 and the first row 0.08. So we can write Pz greater than 1.18 equal to 0.1190. So we compare, we get 50 minus 40 over standard deviation equal to 1.18, and we get standard deviation equal to 8.47.